Welcome back. Today we're going to be answering this related rates question, so let's jump in. Okay, a 13-foot ladder leans against a wall. If the bottom slides away at 2 feet per second, how fast is the top sliding down when the bottom is 5 feet from the wall? Okay, so first thing I'm going to do is I'm actually going to draw a picture to model this situation. So here's my wall, here's my floor, and my wall and my floor are going to meet at a 90-degree angle like that. And then I have my ladder. Oop, like that. Okay, so my ladder is 13 feet, and then the distance from the floor to the wall is 5 feet at this particular time, and then we have an unknown distance here. That said, we can pretty quickly and easily get that unknown distance by using Pythagoras' theorem, the fact that this distance squared is going to be equal to 13 squared minus 5 squared, which makes it 12. This is a pretty classic one that you've seen probably before, so I'm not going to spend too much time going over a Pythagorean theorem, but basically this one would be 12. They've also given us the information that the bottom is going to be sliding away at 2 feet per second. So that means that the x coordinate is moving at a rate of 2 feet per second. And so therefore that tells me that dx over dt is equal to 2 here. So that's basically the information given and a visual diagram of it. All right, so now let's talk about how we're going to solve this. So the first thing I'm going to do is we're going to use Pythagoras, right? So we're going to use Pythagoras in terms of our differentiation. So we're going to state that x squared plus y squared, right? So the horizontal distance squared plus vertical distance squared is going to be equal to 13 squared. Now, why is that the case? Because the thing is, the distance from here to here is constantly changing, right? Because the ladder is falling. Essentially, we have a ladder that's on the wall and it's falling down. Eventually, it's going to hit the ground. And so, therefore, the ladder is going to be coming out this way to more than the 5 feet mark. Eventually, it's going to get to the 13 feet mark when the ladder is fully on the ground, right? And so, however, the ladder is always 13 feet. The ladder's height does not change just because the ladder is going downward, whereas the height it is on the wall changes as it goes downward until it reaches 0. And then the length here between the distance between the wall and the ladder is going to eventually get to 13 feet at the end of this falling process. And the question we're trying to answer is okay, when the number of feet is at 5 at this moment in time here, what would our how fast is the top sliding down, right? So how fast is y changing with respect to time? So we're looking for dy dt essentially because they want to know how fast the top sliding down. So what's the change in the y values with respect to time? Okay, so now I'm going to differentiate both sides with respect to time. So we're going to get 2x dx dt plus 2y dy dt, and that's going to equal to 0, right? Because what's the derivative of constant like 169 or 13 squared? 0. Okay, so now I'm going to plug in what I know. I know that x is equal to 5 in this particular situation. I know that dx dt is 2 as well. And so I'm going to plug those things in. I also know that y must be 12, right? We know that when x is 5, y must be 12 due to the Pythagorean theorem and the fact that we know this must be a right angle where a floor and a wall will meet. So that's going to give me 2 times 5, since x is equal to 5, times dx dt, which is another 2 again, plus 2 times 12 times dy dt is equal to 0. So therefore we have 2 times 5 times 2, which is 20. So 20 plus 24 dy dt is equal to 0. Then if I subtract 20 and divide by 24, I get that dy dt is equal to negative 20 over 24, which is equal to negative 5 over 6 if I reduce that. So the answer is negative 5 over 6 feet per second. Now, the reason it's negative is because this ladder is falling, right? It's coming it's coming downward, not upward at this rate. And here they're asking how fast is the top sliding down. And so since they're already accounting for the fact that it is sliding down, we would choose the positive answer, which is 5 over 6 feet per second, because essentially the negative just means it's falling down, which we already knew, which they're already taken into account. Now, as always, if you do have any questions, feel free to leave those down in the comment section, and we'll see you for the next one.